Good afternoon. Today we're going to do the Trig Day 6 graphing notes for secant and cosecant. What you'll find is once you've learned sine and cosine, doing secant and cosecant is actually pretty straightforward. Okay, so Roman numeral 1, we're going to review our inverse relationships because we're going to use those relationships to graph secant and cosecant from their inverse function. Okay, so our inverse relationships are that sine of x is 1 over cosecant x, and vice versa. Cosecant x is 1 over sine x. For cosine, its inverse is secant, so cosine is equal to 1 over secant. Secant of x equals 1 over cosine of x. Okay, so the first one we're going to focus on graphing is we're going to do a cosecant graph. But first, let's review what it means to have inverse values. Okay, so let's use cosecant x equals 1 over sine x. That's the inverse we're going to use. And we're going to list some values. Sine x versus cosecant x. So we know that sine of 0 is 0. We know that sine of pi is also 0. In between those, we know that sine of pi over 2, or 90 degrees, is 1. Sine of negative pi over 2, or 270 degrees, is equal to negative 1. Those are the ones that we've memorized. Well, keep in mind that secant is 1 over sine. So if we're using x equals 0 to find cosecant, we're going to go 1 over sine of 0. Well, the problem is sine of 0 is 0. You have a 0 on the bottom of a fraction. So cosecant is undefined at x equals 0. Same thing happens at pi. The reciprocal is 1 over sine of pi. Sine of pi is 0, and 1 over 0 is undefined. So cosecant is undefined at 0 and pi. And then now with pi over 2, we have 1 over sine of pi over 2. Sine of pi over 2 is a 1. We get a value of 1. And then finally, sine of negative pi over 2, or 3 pi over 2, is 1 over negative 1, which is negative 1. So how does that influence then what we're going to do for graphing? Okay, so I'm going to just draw a little mini graph here. Okay, so normally your sine wave goes up and then down and then up. That's your sine wave. So at 0, cosecant of 0 is undefined. So at x equals 0, we actually have an asymptote because cosecant is undefined. The other place it's undefined is at pi, which is here. That's pi. So we have another asymptote at pi. And here again at 2 pi. So anywhere the sine graph crosses the x-axis, that 0 gets flipped, or it's the inverse of it to get cosecant, and you have automatically an asymptote. And that leaves us, of course, with these values here. Okay, so let's go ahead and graph. I wanted to show you where the asymptotes were and why, because areas are undefined. So our example that we're going to graph is f of x equals cosecant of x. So what we do with cosecant and secant is we start by doing a graph of f of x equals sine x. And then we're going to use that graph to make the cosecant graph. All right, so let's draw ourselves a nice long axis. And I'm going to push the y-axis over a little bit. Okay, so first thing we're going to do is draw a sine graph. So I'm going to put a 1 and a negative 1. There's our max and our min. I go every other value, so we have a nice smooth curve that we can actually label. So these are all at intervals of 90 degrees. Pi over 2, pi, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, which is 3 pi, 7 pi over 2. This is just our normal axis for a sine or a cosine graph. Negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, for negative 5 pi over 2. All right, let's draw our sine graph. It starts at 0, 0, and it goes up. You have to memorize that. Goes up and then down, back to 0, and it goes back and forth. So top curve, bottom curve, top curve, bottom curve. And we're going to go in the other direction. Bottom curve, top curve, bottom curve. There we go. There's our sine graph. Okay, so as we previously discussed, wherever y equals 0, when that gets flipped, it creates an undefined value. So on this graph, anywhere the sine wave hits the axis is an asymptote. So we have an asymptote here at x equals 0. We have an asymptote at pi. Make it kind of long. You're going to need the space. X equals pi. We have another one at 2 pi. X equals 2 pi. And another one at 3 pi. X equals 3 pi. And then in the opposite direction, I have one at negative pi. And I'll do one last one, negative 2 pi. Okay, so we've got these asymptotes. So where is our cosecant wave? Well, remember, at pi over 2, sine of pi over 2 is 1. When you flip it, you get 1, which is that mark right there. Sine of 3 pi over 2 is negative 1. When you flip it, you get negative 1, which is this value right there. So what happens is when we graph this, we have to mentally know the shape, but you need that endpoint interval and you need the asymptotes to draw it. So it should be a mirror reflection of the curve, except going infinitely up because it hits the asymptotes, and going infinitely down. All right, so one up and one down, that is one period of your cosecant wave. And then the period repeats itself. It goes up, it goes down. Same thing here, it goes down, it goes up, and it goes down. So again, your labeling is going to be these maximums and minimums. So this one is negative 3 pi over 2 comma 1, negative pi over 2, negative 1, pi over 2 up 1. And if you make the loops wide enough, it fits really well. 3 pi over 2 and negative 1, 5 pi over 2 and positive 1. There's two periods of the function. So because the period of sine is 2 pi, the period of cosecant is also 2 pi. So the periods match. Amplitudes match as well, but mainly the period matches. All right, that's how you draw a cosecant graph. Okay, let's do a secant graph now. So example 2, we're going to do f of x equals, and we're going to do a transformation, 2 secant of 3x. Okay, so the reciprocal of secant is cosine. So when you draw a graph to make another graph, it's called a guide graph. So our guide graph on this one is going to be f of x equals 2 cosine of 3x. So we're going to do all the transformations to cosine and only draw in secant at the very end. Okay, so let's start with the period. Our x is being multiplied by 3, so we're going to go 2 pi times 1/3. That equals a new period of 2 pi over 3. So that is a horizontal shrink by 1/3. I just took the b value and flipped it. Then we have our amplitude, and our amplitude is the same thing as our vertical stretch or shrink. So you're going to take and multiply by the a value. Our original amplitude is 1. We multiply it by 2, which is my a value. And the new amplitude is 2, or the vertical stretch is 2. So remember, amplitude is half of the wave. So you're going to have your midline, and it's going to be up 2 and down 2. All right, let's draw an axis. Give yourself some serious space here. Okay, so anytime you get a new period, first of all, let's do the amplitude. Amplitude is 2. So I'm just going to say I'm counting by 2's. 2 and -2. 2 up, 2 down. And normally we go middle, we go up, middle. So our sine wave goes, sorry, our cosine wave goes up, down, up, and then up again. So with our new period of 2 pi over 3, that's where it should end up. So up, and again, you got to memorize how to start the wave. It starts up and goes down. There's one period. So to figure out what our axis is going to be, we need to take 2 pi over 3 and divide it by 2. So that would be pi over 3. Then we're going to divide that by 2. That would be pi over 6. So we're counting by pi over 6's. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6. If you want to reduce those, you can, but in an axis, it's not necessary. You can just go by sixths and not worry about reducing it unless you're answering a question specifically. Okay, let's do the other way. -1 pi over 6, -2 pi over 6, -3 pi over 6, -4 pi over 6. So up 0, down 0, and up again. There's the left side of our cosine wave. So this is a cosine wave with an amplitude of 2 and a period of tip to tip, 2/3. All right, so now we're ready for our cosine wave. We're going to start with the asymptotes. So anywhere that this graph hits 0 is an asymptote. So starting at the left, -3 pi over 6 is one asymptote. And you do have to label that. -pi over 6. Now we've got pi over 6. 3 pi over 6. 5 pi over 6. And 7 pi over 6. And you label those, just like you would any other asymptote. All right, now we're going to put in our secant wave. So anywhere there's a max or a min is shared with your secant wave. So anywhere you have a maximum or a minimum, draw reflected curvature, but then getting infinitely close to the asymptotes. So I'm going to label those in a second. So one period of secant is middle to middle, which is a bit odd. So from here to there, that's one period. All right, last thing we need to do is label our maxes and mins. This is 0, 2. This is pi over 3, negative 2. This is 2 pi over 3, 2. This is 6 pi over 6, or pi, negative 2. This one is negative 2 pi over 6, or negative pi over 3, negative 2. And there is 2 periods of secant. So again, you graph the guide graph, and then you draw the secant or the cosecant from the guide graph. All right, that's everything for today. Have a good afternoon.